Dividing polynomials using long division. Our objective simply, use long division to divide polynomials. Seems rather self-explanatory, doesn't it? We know some things that are going to help us. We know what a polynomial is. It is a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a non-negative integer power. Been there, done that, so to speak. If we go way back to grade 4, perhaps, we know how to do long division with numbers, long time ago. What I'm trying to point out here is the terminology. So 75, the number that's under the division symbol, is called the dividend. 9, I'm going to divide 9 into 75. The 9 is called the divisor. The answer up here is called the quotient. And then when you do all the math, you will have a remainder. If it's 0, that means that it goes in evenly, if you'll remember. Otherwise, it's a remainder that you kind of add on to the end. And it looks like this in shortcut. 9 goes into 75. 8 times plus the remainder. And we write the remainder of 3 over the divisor like that. So how many times does 9 go into 75? 8 plus 3/9, or 8 plus 1/3. Okay, rewriting this with words underneath is called divid, is called the dividend. This part out in front is the divisor. The answer up here is the quotient. And I'm going to add on the remainder over the divisor. That's what you've been doing, or you did way back when. Of course, if the remainder is 0, you're adding on 0 divided by something which is just 0. And so there you probably wouldn't include that piece. If the remainder is 0, the divisor goes into the dividend evenly, which means the divisor and the quotient are both factors of the dividend. We'll see that come to play in some future videos. So what is the process for long division of polynomials? Well, it's quite a process. I'll do 3 examples to help you kind of get used to how this works. There's a lot of words here. There are a number of words here. There's a lot of vocabulary here. But I'll do some examples and you should see patterns form and have it make sense. First, as necessary, we want to arrange the terms of the dividend and the divisor in descending powers of x. In other words, in standard form. If we have a missing x term, we'll write it using a coefficient of 0. We'll see an example of a missing x term in example 3. Now the algorithm starts. Divide the first term in the dividend by the first term in the divisor. The result of that is the first term of the quotient. Then we're going to multiply, just like you did. Multiply every term in the divisor by the first term in the quotient. Write the resulting product beneath the dividend with like terms lined up. Step 4, I put a little star next to, because it helps us not lose track of our negative signs. Enclose your resulting product within parentheses. I will do that all 3 times, in all 3 examples, I should say. Then I'm going to subtract, as you see up here. Then I'm going to bring down the next term and repeat. And I'll repeat all along until we have finished up with all of the terms in the dividend. Okay? Let's do some examples. It'll make a whole lot more sense as you see the numbers that go along with it and not just all of that math lingo, although that math language is important to know. Okay. Use long division to divide x squared plus 10x plus 21 by x plus 3. And then when you're done dividing, the question is x plus 3 a factor of x squared plus 10x plus 21? In other words, is the remainder 0 or not? Okay, notice they're already This is in standard form, highest power to lowest power. This is in standard form, so we can divide. So x plus 3 is our divisor, and underneath our symbol is x squared plus 10x plus 21, our dividend. Here's the first step. How many times does x go into x squared? Okay, so x squared divided by x equals what? And the answer, of course, is x. So x goes into x squared x times. Write it above the x column, so I'll put it right here. Now multiply. X times x is x squared. X times 3 is 3x. So I've multiplied. Now enclose it in parentheses. You'll see how important that is in examples 2 and 3. And then subtract. We know we did this on purpose, so we know this is 0. What is this one? Well, 10x minus 3x is 7x, and there is our difference right there. Now let's repeat. Well, excuse me, let's first now bring down the next term. The next term is 21. Now repeat. How many times does x go into 7x? Well, x goes into 7x 7 times. So I'll put a plus 7. And again, notice my 7 is written above my 21. My constants are in this column. 7 times x is 7x. 7 times 3 is 21. Parentheses, subtract. Well, 7x minus 7x is 0. Well, that was the reason we put a 7 up here, was to make this first subtraction a 0. 21 minus 21 is also 0. We're done. And so we know that this is our remainder. We have a remainder of 0. Okay, so we've used long division to do our division, and we have a remainder of 0. Is x plus 3 a factor? Yep. It goes in evenly. There's no remainder. So yes, x plus 3 is a factor of x squared plus 10x plus 21, which means that our quotient is also a factor. Had we just factored this, you would notice if we just factored this, that would be the quick way, but it gives us a way to give it a quick check as well. So x plus 3 is a factor, x plus 7 is a factor. Each of these go into this evenly with no remainder. Let's write it using our division notation. So we have x squared plus 10x plus 21 divided by x plus 3. That's our division problem. The answer is the quotient, which is x plus 7. This is the quotient, plus the remainder. The remainder is 0 over the divisor, over x plus 3. And that's our remainder right there. So this divided by this equals this plus the remainder. Of course, the remainder is 0, so it just equals that. Okay, let's throw a couple, let's put some negatives in there a little bit so we can see how that works. We'll also note that this one is not written in standard form. We want to make sure it's in standard form. So a couple of changes. Example 2. Divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. Is 3x minus 2 a factor of this? Does it go into it evenly? Is the remainder 0? All those are the exact same question. Well, this is in standard form, highest powers of x to lowest powers of x. This one is not. So when I do the division, that's my divisor. I want to write the dividend with my in standard form, highest powers of x first. So 6x cubed minus x squared minus 5x plus 4. Okay, that'll help us. So now, again, we start first term in my divisor, first term in my dividend. How many times does 3x go into 6x cubed? Okay, well, let's see here. 6x cubed divided by 3x is equal to 2x squared. So 3x times 2x squared equals 6x cubed. It's a squared term. I'll write it above here. And I have 2x squared. 2x squared times 3x is 6x cubed. Well, that's what we wanted. We want it to equal that first one. 2x squared times negative 2, don't lose the negative, is negative 4x squared. Parentheses, subtract. See the parentheses come into play here. Don't lose track of your negatives. 6x cubed minus 6x cubed, that's 0. That was our goal. That's why we chose this. Negative x squared minus a negative 4x squared is the same as negative x squared plus 4x squared, and that is 3x squared. Gotta be careful. You can lose track of negatives and double negatives with all this subtraction going on. Bring down the next term, which is a minus 5x. Repeat. How many times does 3x go into 3x squared? Well, just an x, because x times 3x is 3x squared. And then x times negative 2 is negative 2x. Parentheses, subtract. Okay, well, 3x squared minus 3x squared is nothing, but that's why we chose it. That's why we chose x up here. We wanted to get 0 from the first subtraction. Negative 5x minus negative 2x is the same as negative 5x plus 2x, which is negative 3x. Bring down the final term, plus 4. Repeat. How many times does 3x go into negative 3x? How about negative 1? Write the negative 1 above the 4. Negative 1 times positive 3x is negative 3x. Same. That was our goal. Continue the multiplication. Negative 1 times negative 2 is positive 2. Parentheses, subtract. Well, negative 3x minus negative 3x is nothing. That's a plus. 4 minus 2 is 2. So there is our remainder. We have a remainder of 2. Well, that tells us something right away, that 3x minus 2 is not a factor of this piece, this third degree polynomial, because the remainder is not 0. So no, 3x minus 2 is not, it doesn't go into it evenly. It's not a factor of, and I'll write it in that form there. This is 6x cubed minus x squared minus 5x plus 4. Okay, it's not a factor. It does not go into it evenly. Therefore, it is not a factor. So let's write it out as a division like we did up here at the bottom. Let's see here. We've got 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2. That's what we just did using long division. We got a quotient right up here. Our quotient is 2x squared plus x minus 1. That is our quotient. And we have a remainder. Okay, the remainder in this case is 2. And we write the 2 over the divisor, which is 3x minus 2. And this is our remainder. And again, if I could spell remainder, it looked like I lost track of the I. R-E-M-A-I-N-D-E-R. When we have a remainder that's not 0, that means it's not a factor. Okay, we'll do one more. Give me just a moment here to get my act together. All right, I think I've got what I'm looking for right here. Example 3. Hopefully you're starting to get the hang of it a little bit. This example throws one more little piece at you. Divide. I don't think my paper's very straight on your end. Let's see if I can get it straightened out. Hope that's better. Hard to tell sometimes. Divide a fourth degree polynomial, 6x to the fourth plus 5x cubed plus 3x minus 5, by a second degree polynomial, 3x squared minus 2x. Is 3x squared minus 2x a factor of 6x to the fourth plus 5x cubed plus 3x minus 5? In other words, is the remainder 0? Okay, notice we are in standard form. Okay, the exponents are non-negative and they go from least to greatest in both the dividend and the divisor. But notice here we're missing an x squared term. So I'm going to slide my sheet down a touch. We need to include a 0x squared when we go to do our division. All right, looks like maybe I need to do a little bit of get my paper figured out here to get it so it's clear. Sorry about that. Looks like I've lost some clarity. There we go. I think I'm back. Okay, we need to include an x squared term. Okay, so divisor, 3x squared minus 2x. Dividend underneath the symbol, 6x. Whoops, how about a 6x? 6x to the fourth plus 5x cubed plus 0x squared, that's the different here in this problem, plus 3x minus 5. Okay, got a lot to do. Let's start. How many times does 3x squared go in 6x to the fourth? Again, 6x to the fourth divided by 3x squared. Well, that is 2x squared. X squared row column is this one. So it goes in 2x squared times. Multiply. 2x squared times 3x squared is 6x to the fourth. Well, that's what we wanted. So we know that we want to match the first one up. 2x squared minus 2x is a negative 4x cubed. Parentheses, subtract. Again, the parentheses assist us in not losing negatives. This is 0. We knew that. This is 5x cubed plus 4x cubed, which is 9x cubed. Okay, bring down the next term, which is 0x squared. Repeat. How many times does 3x squared go into 9x cubed? Well, it goes in 3x times. So plus 3x. 3x times 3x squared is 9x cubed. And we wanted these two to be the same. That was why we chose 3x. 3x times negative 2x is negative 6x squared. Parentheses, subtract. 0 for the first. 0x squared plus 6x squared is 6x squared. I should say 0x squared. 6x squared, bring down the next term. And repeat. How many times does 3x squared go into 6x squared? Well, that's just 2. 2 times 3x squared is 6x squared. Again, same. That was the goal. 2 times negative 2x is negative 4x. Parentheses, subtract. 0 here. This is going to be 3x plus 4x is 7x. Bring down. Okay, I get to stop here. Okay, I stop here because the degree of this one is a 1 and the degree of this one is a 2. So I'm 1 degree less. There's no way that 3x squared goes into 7x because there's no way to multiply something times x squared and get an x. So this turns out to be the remainder. Okay, and of course, as I mentioned, the degree of 1 here is less than the degree of 2 in the divisor, so we stop. Okay, so we didn't get 0. Is 3x squared minus 2x a factor of, of this? Nope. No. 3x squared minus 2x is not a factor. It does not go into it evenly. It is not a factor of 6x to the fourth plus 5x cubed plus 3x minus 5. Okay, now let's write that as we've written it before, kind of the whole division that we just did. We just did 6x to the fourth plus 5x cubed plus 3x minus 5. And we divided that by 3x squared minus 2x. And we got a quotient. Whoops, I got too high on my sheet. This is the quotient right here. So I'm going to rewrite that down here. The quotient is 2x squared plus 3x plus 2. And again, this is our quotient. And we got a remainder, and the remainder is 7x minus 5 right here over the divisor, which is 3x squared minus 2x. And that is our remainder. Okay, it takes a bit of work, obviously, but I don't think it's overly complicated. It just takes some practice to get the algorithm figured out. And you need to be careful. I want to impress upon you one more time before you go to subtract, and close these things in parentheses, because you'll lose track of these double negatives going on if you're not careful with that.